All right, this is the solution video for Unit 2 review, problem number 9. All right, find all values for A and B so that G is differentiable for all real values of X. All right, so first of all, we want to consider differentiability. So 3x plus 5, that's a line, right? There are no jumps, asymptotes, holes, corner points, anything like that. So that is continuous and differentiable everywhere. And then ax squared plus bx plus 1. Yes, we don't know a and b, but this thing is a parabola. So of course it is continuous and differentiable everywhere. No jumps, asymptotes, holes, corner points, cusps, anything like that. So really, all we're concerned about is x equals 2, right? So we want to check continuity at x equals 2, and then we want to check differentiability at x equals 2. So we're going to evaluate f of 2. All right, so f of 2 means to plug 2 into the bottom piece for x. So a times 2 squared plus b times 2 plus 1, right? That's f of 2. Then we need, in order for this thing to be continuous, we need the limit as x approaches 2 to exist as well, right? So limit as x approaches 2 of g, well, remember, that would just mean, well, that we have to consider the limit from the left. So that would be plugging 2 into the bottom piece, which is the same as f of 2. So that would just be 4a plus 2b plus 1. All right. And then we need to make sure that that is equal to the limit as x approaches 2 from the right of g of x. All right. And so what is the limit as x approaches 2 from the right? We plug 2 into the top piece. So 3 times 2 plus 5. So 6 plus 5 is 11. So in order for this thing to be continuous, we need 4a plus 2b plus 1 to be equal to 11. Or you could say 4a plus 2b equals 10. All right. Now, the next thing we need to do is we need to consider the derivative. So now I evaluate the derivative of g. So derivative of 3x plus 5 is 3. So that is the derivative when x is greater than 2. And the derivative of ax squared plus bx plus 1. Remember, a and b are constants. So the derivative of ax squared would be 2a times x to the first plus b, and then plus 0, right? The derivative of 1. Now that's going to be good when x is less than or equal to 2. We can include 2 because we know that these two things are going to have to be equal. All right. And so we want to set g prime of 2 from the left equal to g prime of 2 from the right so that this thing is differentiable. All right. So what is g prime of 2 from the left? That would be plugging 2 in for x uh, to the bottom piece. So 2a times 2 plus b. And then we need to set that equal to g prime of 2 from the right, which would just be 3. And so in other words, we get 4a plus b equals 3. All right. And so then we're going to bring these two equations together. So I'm going to bring this one over here. And I have 4a plus 2b equals 10. And so we're going to subtract, right? So 4a minus 4a obviously is 0a. B minus 2b is negative b, and 3 minus 10 is negative 7. So b must be positive 7. All right. So that is b. Now we pick one of the two equations. How about this second one there? So 4a plus b, which is 7, equals 3. All right. So 4a equals, I'm going to subtract 7, so negative 4. So a is equal to negative 4 over 4, or negative 1.